Hello all, welcome to my channel. I'm here with another video. In this video, we will see how we can debug in Spark job using web UI. So it's not something that we will debug a job failure. This will be something as a guideline that how we can use the Spark web UI to find out what is going on with the job. Before we go into looking at the things, just a quick refresher that how a Spark executes a pipeline. So one pipeline can have multiple jobs. Each job is mapped to one task. Each job is mapped to one action, and each job then further gets split into multiple stages. Each stage is separated by another stage by a shuffle exchange, and then stages gets split up further into tasks, and tasks get executed on the executor. And if we are using any type of cache or persist, then that gets stored in the memory or in the disk based upon the label that we have used. There is another concept which is called DAG, and there are other things. There are certain plans which are uh, seen during the execution of a job. Is plans like logical plan, physical plan, analyzed plan, optimized plan. So that kind of plans are also there. The reason why I'm telling this thing is we get to see all of this in the Spark Web UI. So that's why I wanted to just do a recap of how things happen in a job. So what happens is when we start a job, if we have not done anything customization on our Spark clients, by default there will be a web server which will run keep on starts on running on uh, localhost port 4040, and this is the live web UI. We also have an Spark history server UI which we have to configure separately if we want to use it with our cluster. We provide the event log directory, and then it starts to once a job finishes, the logs are moved, the logs from that are served in the Spark history server UI. So these two things are important to know, that this web UI, the live one, uh, is only available till the job is running. But if we want to see after something has happened, the job has stopped, then we have to go to the history server. Now, coming to the web UI, Spark web UI gives us different information. As I was mentioning, it provides us the Spark environment details. So environment details are something which are like how many executors, how many cores, what was the executor memory, what was the driver memory. So anything that you pass using a Spark hyphen, let's say you are passing it through a command line argument. So it will be like hyphen number executors. So anything that you pass from there is recorded in the environment details. Anything which has been set by the default uh, properties of Spark client, that also will be displayed in here. Some properties related to Yarn, Hadoop will also be shown in here. Nodes and executor metrics, this is something which is shown in the history UI. Then we have environment properties and parameters, like if we have set any what you called any environment variable while we are working with the system, that will be shown in the UI. Jobs, how many are running, how many completed, how many terminated, which were failed, that kind of things. The DAG visualization will be shown. DAG will be for a stage, the DAGs will be there. Physical and logical plans we can see in the SQL queries, job status, task, user metrics. So all these things I've already talked to how it is shown. Now let's see if I show you one this thing. So this is one project by one folk from Databricks. He has uploaded this, so we can use this to just walk through the process of seeing how we are moving from one pane to other. This is slightly different, but everything from this line onwards, it's same as what you will see in a Spark UI. So it has jobs tab. So once if you click on jobs, then it will say how many jobs are running. This is jobs on of an application. So there is one more page when you log in the normal UI, you will see a page which says applications, and when you click on Spark application, then it will come to this page which is jobs. So it has event timeline. Event timeline says gives us two information, like when was the executors added, when was the driver added. So see, first the driver was added, then the executor was added. Timeline wise, this is the time through which this page is going. Then one job got triggered, job got triggered, like this is the timeline of the different jobs that got triggered. Below, if you see completed jobs, so which jobs completed, how many are failed, so which one were failed. So this is uh, in the job page. So the job page, we have timeline. So this I've given another example. If you see here, so executor driver added, then the executor added, and once this executor was added, there were two jobs triggered and that completed. Then again, one job was triggered. And in this case, this application was having dynamic allocation. So see, initially it only launched one, and after that, when they started this job, it found out that okay, I need more executors to process this job. So again, executors 2, 3, 4, 5, 6, 7, 8, 9, those were added. Then if you see another 10, 11, 12, 13, 14, 15, 16. So likewise, these executors were getting added. And this job completed. Once this job completes, these are executors will have another timeline, flag here saying that okay, executors removed. So this is how you will see in your UI as well. Now, things to note is so when you see a gap in the execution, so this is why this is important to note is that let's say you see so this is fine, like it executor first of all driver was added, then after some time the executors were added, and then after some time, see, once the executor was added, or till the time once the driver was added, executor was added, after that sometime there's a gap, then this job started. So what was that gap? Why was there a gap between the executor getting added and a new job getting launched? See, so the reason is when you see a gap in your job timeline, that means that there is something which is happening on the driver, which is non-Spark code. For example, let's say if I want to simulate this, that okay, I want to have jobs which show you that something else is happening in the Spark driver code. So if you say uh, we have a code, let's say spark.read.one file location, and then I say spark dot sorry let's say python dot in python modular, let's say we have sleep, so we say sleep for another 5 minutes, and then I start another process. So there will be a gap of 5 minutes between one job and another job, because there is nothing happening in between those two which this job timeline can show, because that is a non-Spark code. So sleep is a non-Spark code which is running on the driver. So driver is sitting idle before moving on to the next job. So that's where things are important to note, that if you see a gap, so there is something which is non-Spark code that is running, or driver is compiling a complex execution plan. So see, let's say for example here it's a it took some time here. So it was trying to compile the code and then see what is the execution plan that I need to run. So at that time also is displayed in here. You will see a gap. Or maybe driver is overloaded or busy, so it is not able to schedule any new job. So then also it will see a gap. Or there is one more case that where the class driver has asked for resources from the cluster manager. Let's say it asks for certain executors before it can launch a next job. But what happens is that let's say if we are using external systems like Unicorn or GAN-Q, and if there is no proper resources to be allocated at that time, the driver will keep on waiting for the resources to come, and it will not schedule any new job. So you will see a gap in the two jobs timeline. Or if there is nothing else to do, you will also see a gap. So this is one thing to note. Again, once you have see there are failed jobs, so why as we showed in this graph here, we have some failed jobs, and why it was failed, we will see why it failed. And we can see which job failed. We can, if want to debug it, we can go further. And in the timeline here, as I mentioned, these are executors added. Then we will also see places where it will say removed executors. So let's say if we are not using dynamic, one example was when we are using dynamic allocation, you will see that it keeps on adding and removing executors, so you will see executor removed. But let's say if you are not running a dynamic allocation, you are running with static allocation in Spark, and still you see, if you see something which says executor removed, that means something is wrong with your job. Either the executor is running out of memory, or the on the node on which that executor came, the node itself tried to kill that particular executor. Let's say in case of Kubernetes, the host evicted that executor part because of it had memory pressure or something. So that also you will see, it will say that executor removed. So this is about all the jobs page. Then once we have jobs, as I was mentioning, that jobs get split up into multiple stages. So and similarly, what happens is in the web UI, from one job you can go to its stages. For example, let's say this was a job page that we were seeing, and let's say we want to see stages of a particular job. Let's say this was the first job that got triggered, and we want to see, or let's say this one, it has some task as well. So let's say we want to see what happened to this stage. So we will click on this, and it takes us to the details job page, and here it will show what is happening in this job. So this is the timeline, what was the DAG visualization that we see, like how it is, what it is doing. It will say what is the stage. So there is one stage, and then if we click on this stage, it will take us to the, okay, what was happening in this stage. So this gives us a plan, this gives us an executor timeline, this gives us other things. So let's go through that first here. So once in the stage view, we see certain information, like on the top we'll see DAG visualization. So this is what is happening in the job, what is happening in this, not a job, but a particular stage, like what is happening in here. So it is reading from RDD, it is doing something, and then it is again writing back to somewhere. So this is the execution flow. This is just a symbolic representation. Your job, depending upon what you are doing, it will have more or less nodes. And the stage tab will also have an event timeline. So I was mentioning in here, if you see, the timeline is like this. So it includes this is an executor timeline, sorry, worker or executor. You can say worker or executor both, any one is fine, but this is for executor timeline. So what it does, see, it says scheduler delay. So how much amount of delay was there in the scheduler. So there is I will make a different video why there we see a scheduler delay. Then we have executor computing time. So this was a time when executor were doing some actual work, this green line. And let's say task deserialization time. So this is important to know that whenever we create a function, or whenever we write a Spark code, so the task that gets executed on the executors are first serialized in the driver and then sent to the executors. So executors picked up that serialized object and deserializes that and creates a function that should be run on the executor. So that's this is the task deserialization time that is coming. So here, if you see, this is a very big timeline. So this took a very long time to serialize deserialize the task. So something that we have to look at, why it is taking that much of time to do a serialization. Similarly, if we have result gathering, we will see result serialization, shuffle write, shuffle read. All those things are mentioned in this time. It will appear in the timeline. So here in this case, if you see, we have here it says shuffle write time. So this executor, while it was processing, it did have a shuffle write, and then it also has a result serialization. So before sending it to the driver, it serialized the task output and then send it to the driver. So if you see, slight purple color bar is here in this at the end. So this is, you will see in the stage, and then we will see a metric for that particular stage as well. This, like this table which says shuffle read write, read size and record, shuffle spill, and shuffle spill to disk. So these are metrics aggregated by the executor. So executor ID 1. So let's say that we have, this means this we have four executors. One executor 1 read 18.6 GB, and it had to spill 98.1 into memory. That means it has to spill something, and the in memory size of that thing was 98, but when it was and the amount of data that it had to spill on disk was 16.8 GB. Similarly, for others, like the executor 2, it had 117 GB to read and 17.3 GB to spill to disk. So that way we see what is happening with the executors, what they are trying to do. It mentions input, output, shuffle read, shuffle write, all the details. And then it will also tell us how many number of tasks which are running, right? So if we say only one task, that means that we have a single partition workload like coalesce. Let's say if we have coalesce one or repartition one, or let's say if we have a window partition operation where partition by is not there, then we will see only one task which is running. That means that there is only one process which is going through all these processes, and hence we see only one task. So that is something that has to be looked at. Then in the same view, we can also see this tab which says for what was the uh, 25th percentile, median, 75th percentile, and max. So this is something important. This identifies what we should be what we should be interested in here is to see is there any skew. That means that okay, let's see, minimum was 8.3 MB and the maximum was 10.1 GB. You see, there is a huge gap. So on a median size, it was 36.1 MB. For 75th percentile, also 92.9 MB. So what this shows that there is a huge skew in the job. That's why certain partitions or certain executors are receiving more works. That's why it says 10.1 GB compared to 92.19 MB. So this if we look at this, we will be able to find out where is the skew happening in the system. Then we have other metrics like here. This was for output size record or suppose read size records. We also have GC time. So in general, lower the value of GC, better the approach. Here there was no GC happening, much of GC happening. But if you see for certain tasks, it was for 1 second GC pauses were there. So this also we can find out if we see there is a memory leak or GC as well. If it is present, then we have to handle that. So let's go back to here and see all those things here. For example, in this case, we have duration. This seems pretty what you called stable kind of scenario. We don't see any skew like duration 7 minutes. 7 second was the smallest task, and 8 second was the biggest task. Biggest or the task which run for the most duration was 8 seconds. So this is fairly distributed. Also, we have option of seeing the logs. If we click on these logs, we will see the log of that particular executor. Like this is executor 0, executor 1. So we can see the logs of that. And then here we have again, this is the task. So as we know, if we have only, so executor ID 0 means driver. So this is driver task, driver, and this is 1 is executor. So only one executor was running for this job. But if you see in here, you will see there were multiple tasks. So task ID 13572 something like that. So these tasks, if we want to see the logs of this, we can click on this and see the logs of individual tasks. If we want to see the whole log of the executor, we can click on here std out or std error to see the logs. One thing to note is anything that we mention in a print statement in our application, that is available in the std out of the driver, not on the executor, because the print statements are executed on the driver, and hence the results that you see, this I have mentioned somewhere, any print statements in the part of the DAG shows up in the driver logs. So that is something we have to see. Now once we have known these things, that okay, what is stage and all the details in the stage, now next becomes what, which task is running on which executor. So we have an executor tab. So if I uh, go here, sorry, if I go back to this task, let's say if I want to let's say if I click on stages and I am into a stage, if I click on one particular stage, then we have details of the stage. Again, these things we have discussed, and the memory and everything we can see. Now if we click on the executors tab, so this will be executor tab. So driver is, sorry, my bad, driver is separately mentioned in here. So executor ID, but in Kubernetes I have seen executor ID 0 means driver, and but here it is explicitly mentioned driver is different. So there were two executors running, my bad. So that is something which we can see in here. If we want to see the logs, we can click on logs in here, heap histogram, thread dump, everything we can do it from the executors tab. So here in the executors tab, we also see a summary basically. Those summary is how many tasks were successful, how many failed tasks, what is the reason of the failed task. For example, let's say we will simply see summary like this, which says failed task. So how many tasks were failed and why it failed. For example, here, if we click on this, we will find out why this task failed. So what this is saying that this executor ran some tasks. It had only one core and it run so it in total, see here it says this executor ran 106 tasks. Out of those 106, two tasks failed, and those two tasks were it may happen that those two tasks were something which was transient, so it went into a different executor and then it succeeded, or maybe something else was happening. That's why this retry happened and it again failed. So see, there are others as well. In here also, one task failed, and this one was two. So for some reason, this executor failed twice, others failed only once. It might happen that while we were trying, then we pressed a Control C and killed that application, and hence this all the tasks which were in running process got killed. So something like that can happen. But if you see the summary wise, you will say five tasks in total that failed, and completed 477, total were 422. And if you add it in here, break down by executor, we will see the same thing. And if we want to see the logs, we can simply click on this std out and std error. So this is on the executors tab. Also, we see the details like which executor has how many cores. So based on the cores, it will decide how much of memory, sorry, how much of parallel tasks it can run. So coming back to here, so executor tabs, we have seen something similar we will see in there as well. Then comes the SQL or data frame tab. So this for every job we will have an associated link in the SQL tab. For example, let's say this is under the SQL data frame tab, you see this is the ID. It says which job ID this is linked to. Based on that job ID, we can click and see what is the plan that got executed, and it will show something like this. This is very important. This is where you will see performance issues if you want to debug for slowness or something like that, because this gives us uh, a full view of what is actually happening from a physical implementation point of view. All other things like DAG, they were showing the logical plan. This is the one which gets executed, kind of, if we don't have if we have AQE enabled, this gets updated. So always we have to see once the job has executed, then see the what was the plan that was executed. But in case of AQE is not enabled, whatever it's on, that becomes the final plan. So here, if you see, it says whole stage code gen. This is something which we have discussed in one of earlier videos as well. And then this scan is, it is trying to scan two JSON files parallelly. That the scan it not necessarily parallelly, it might have done sequentially, but from the flow wise, it seems to be they are independent basically. So they were scanned from the file location. Then there is this exchange. This is nothing but a shuffle. So that shuffle happened, and shuffle happened because they wanted to do it join. So if you see, while did the scan, so how many records it totally outputted is 1961, and this side it was 10,000 rows. And then the size of the data, how much data was shuffled. Then because it is using a sort merge join, before doing the join, it does a sort on both the sides. And doing the sort, what was the peak memory that it used? So it says 6 point peak memory total is there. So minimum, median, and max. So that is like total memory was 6.3 allocated to this particular executor, this task. And then see 32.1 MB was minimum, maximum, and mix are all same. So that means that this whole thing, when it was sorted, it required 32 MB. And the same on this side as well. And then it did a join, and on the join, how many records it outputted is 10,439. So every record which was present in here had a matching record in here. So it did that many records came up in here. So this is this is something which we have to be pay attention to, that when we are implementing, can the filters are doing right thing, that we can do. See, if we observe the substantial difference between data that we are reading and data that we are using, then we have to improve the layout, or we have to do the predicate push down and stuff like that. a type of join, like here it says sort merge join. And let's say if we know that instead of sort merge join, if we do a shuffle as join, for example, this is very small table, we could have done a shuffle as join, or we could even have done a broadcast join. That could have worked. How much shuffle is happening, can be record shuffle, reduce the shuffle, that also we can see from here itself. And also once we click on this plan, below we will see a details page which says the physical plan that we see, the past plan, analyzed plan, optimized plan, and then the physical plan. So that physical plan also we can see, this plan is what it is showing in here in a UI fashion. But if we want to, let's say if we want to pass this to a system which analyzes the plan, then this is the place where we can get this and then send it to the system to plan that. Similarly, so we can see in SQL tab in here as well. For example, see it says it is linked to job 21, 22, 23, 24, 25. So let's say we want to see what is happening in here. So we click on this. So it did a scan, it scanned some scanned, and then after that scan, it did a project. After the project, it did some exchange, and after this exchange, it did some shuffle reader, shuffle writer. Then it did a sort, then did a sort merge join, and skew is true. So here it is using the EQE, and skew join was enabled. So it did it says that, and it did join, and then it again it did a exchange and sorted it, and then gave the output. The reason this sort is happening is because let me show you the code for this. So if I show you here, what is the code that is getting executed, which the plan is for, is this one. So here what we were doing is we are reading this data frame, so that was one. Then we did a did a join. So if you see, after join we are doing an order by, and then we are doing a write, and hence we were saying that that particular plan, sorry, where it was, is one. So we were saying an exchange, and then this sort is because we had done an order by, and then it says adaptive spark plan, and then override by expression, which is because we are writing it to a location, but it was a no op, so it didn't do anything. And this is what I was saying, that this is the plan that gets generated, and this is the one which gets used. So this is one thing to note. Then we have streaming tab, and we also have storage tab. So storage tab is nothing but if we are doing any cache, or we are doing any persist, that those things will appear in here, that what we are doing. So it says that okay, 51 GB of disk cache was used, and certain data was read from IO, cache, cache hit, cache miss. So if we are doing a cache, and if we are running out of memory, we can see it in here that what is happening, how much we are caching, is that cache being really useful, because this, let's say, cache hit ratio, cache miss ratio is something which should be important to know, that whatever we have cached, this is not available, I guess, in the whole normal OSS Spark. It is, I think this one is only available in the Databricks UI. So this is one thing to note. And then we have streaming tab. This is for if we are running a streaming application, then we will see this streaming tab. And in this, it also, it is same as what we had seen earlier. It will say how many batches it had completed for each batch, what is the details, which file stream that we are taking, and what is the streaming applications events coming from, how many events were consumed, and how many are being processed. So that kind of information is available in here in the streaming tab. So let's see if there is one job which like it says that okay, there was a simple stream job, a stream which finished, and all the details like input, average input per second, and average processor per second. Well, means in 1 second how many input records were there, how in 1 second, how many batches it processed, how many error and stuff like that. So this is available in here. Let's say if we are using, there is one more tab which comes up if we are using, let's say, thrift server, Spark thrift server. So there will be a JDBC ODBC server, which is here, which will be there in case we are using Spark thrift server to launch applications. And so there are use cases where this is used. For example, if you are using analytics in database, which is, let's say, very big, but it is not able to handle, let's say, very huge amount of data, and it wants to offload some of the work to Spark. For example, at scale is one. So we can integrate at scale to query Spark, query using Spark SQL, which is using the chip server. What we do is we create a JDBC look endpoint for a Spark cluster, and the at scale application will connect to that JDBC server and run the applications there. So all those things that are coming from that side will appear in this JDBC page. So this is how you will see how you can use Spark Web UI to find issues and what is. So the things that we have to look at is duration, resource allocation, garbage and shuffle. What this means is look for stages with unusually long execution times, resource allocation, check for executed CPU and memory to identify underutilization or overloading. Check for allocation of time across tasks, investigate min, max, median duration across tasks for skewed or workloads. Then look for GC. If high GC, that means there is a memory pressure, and see the shuffle read write that is happening. And if you are able to identify these things, you will be able to fix what is going wrong with your job. So this was it. Hope you like it. Have a nice day.